Picture this. You're in a car and you zoom past an idle cop. His speedometer reads an absurd number, and so a chase ensues. In this case, the speed of this object, that being your car, is detrimental to determining its position, as it is in every case. Or is it? The answer is almost. While it is certainly true for objects that we can see with our naked eye, be it a baseball flying in the sky or a bullet train rushing towards its next stop, that idea falls apart completely when you venture into the subatomic world. You see, when you're dealing with subatomic particles, that is, particles that are smaller than atoms, we run into a problem, a paradox if you will, where whenever you get closer to determining the velocity of one of these particles, you aren't able to determine its position, and vice versa. This is colloquially known as the uncertainty principle. Heisenberg's uncertainty principle, to be more precise. This principle was discovered by Professor Werner Heisenberg in 1927. Initially, Professor Heisenberg used the observer effect, which basically says that looking at an object, such as a subatomic particle, using observational tools changes the properties of said object, to explain why the uncertainty principle was a thing. However, since its discovery, scientists have proved it to be a fundamental property of quantum systems. But why exactly is this true? Well, the answer has something to do with wave-particle duality. Put simply, everything which has mass, aka matter, can also be described as a wave. The smaller the mass, the larger the wavelength, hence why this concept is tied to the uncertainty principle. Essentially, when you're measuring a subatomic particle, you're measuring a moving wave, which has velocity, and a particle which has position at the same time. With this knowledge in mind, let's try and understand what that means. Now, imagine a video. When you play the video, the speed at which the video plays is like the velocity of the moving wave. However, when you want to find a specific part of said video, you have to pause it, which means that while now you have the certain location, the speed of the video is 0. You're essentially looking at a picture, which is similar to a particle, a frozen moment in a continuous cycle of moments. This is what the uncertainty principle captures, the inherent impossibility that lies within quantum mechanics, absolute precision when it comes to measuring every aspect.